There you go.
Yay, I know.
Can you dial in at?
Can you see us?
He's got us.
Can you see us?
Yeah. What is the dial in? What does dial in mean?
Just hit the sand button. Okay. No, he's already done.
9124 1.
Please enter your access code followed by the pound or hash sign.
797 796 701.
To enable audio controls, please enter your audio PIN followed by the pound or hash sign.
All right, now we can hear each other, I think. Sorry about the confusion there, Anthony. Thank you so much for your patience. Can you see us? Awesome. So, let me switch presenter. Hold on here one second.
You want to pre-connect it, Eric, before we just talk to
I want to get this set up here real quick.
expand it back out first.
Switch presenter. You make presenter. You should be presenter.
And hopefully you're seeing that.
Awesome. So, again, guys, this is Anthony Hauck from Autodesk, and he is going to show us some of the stuff related to AI type stuff, algorithms and stuff of that nature, and how Autodesk is using it for generative design. Perhaps, Anthony, you could go over exactly who you are there and what it is that you do, and tell us a little bit more about generative design. Thank you, sir.
Sure. I'm the director of product strategy for the AEC Generative Design Group, which was a group that formed June 2015 or so. And I'm coming off about 8 years of running product management on the Revit team. So this group was formed with a few products in it, with Dynamo, which all permutations of Dynamo in their Format, Insight 360, and Project Fractal, which I'll show you. We're coming from a premise of being able to record logic, set goals, and constraints should lead to computational production of options that hopefully result in having better buildings for designers. I'll note that, right now, even I consider our work fairly primitive, but we are in alpha with Project Fractal, so with only half an hour to try to go through this, I'm going to try to be a little speedy, but I'm going to, instead of showing you Fractal to begin with, I'm going to show you some things in Dynamo just to demonstrate that it's not a whole lot up my sleeve. So we're starting here, and I'm going to speak to be able to see you as I make this current, but make a noise or put something in chat if you need to interrupt me and catch my attention. But this is kind of ordinary Dynamo Studio, ordinary graph, nothing very exciting here. I'm going to hit run, and just let this run to show you what this graph produces in about, 5 seconds or so. So we've got something, this is called building shell and facade generator. It's nothing, there's no kind of radical nodes in here. There's nothing special going on. I'll call your attention to this area in the graph with a couple of inputs of numbers of stories and first story height, horizontal window subdivision. Hold those thoughts. I promise I will show you the transition, but I'm going to go right into Project Fractal where you're going to see something similar. I'll point out this is not a piece of software. This is a service. You're looking at it in an ordinary Firefox browser. see the thing starting showing up on the shading and wall ratio, which is in the case of this graph more like kind of a performance result. So obviously the output of all this is deterministic because it's only the possibility that you put in the graph. We're looking at some other possibilities in the future for development of graph interaction that will make this more serendipitous, perhaps.
Keyword.
But anyway, let me stop there and go back to seeing the room any second now. So, questions, comments, info, diatribes? What do you got?
Has the option to use, like, I've been using it now for whatever it's been, 2 weeks, and I never noticed that I could use the actual graph up top as a filter.
No, it's not obvious, and that's good feedback. I mean, we get so used to playing around with this stuff, and we sort of forget that, the first time some of us saw it, it was like, oh, the parallel coordinates graph is cute, what's that for, right? Filtering, and also, I don't know if you guys noticed as I was looking through here, but as you hover over each one of these, you can see where it's hitting the parallel coordinates graph. So you can see also how, I'm not even sure what's happening there, where this thing kind of went off the mid-range, but it's possible that the way this graph works, there are several of the sometimes misspelled verticals that are influencing where the plan would fall.
That's pretty amazing. Yeah.
So Anthony, Kenneth here just gave a talk on random and mutations and stuff like that. So is there a possibility that this, for finding things that you're not looking for, is there a possibility that this would have a separate area? You were talking about random stuff before, that it would create that in addition to what you're actually trying to look for, to give you something else that you might discover.
Yeah, with your indulgence, I'll resort to a video because the actual graph that does this is in some mid-state right now. I'm in the middle of revising it. Not that I wrote it originally, but there's some stuff I'm adding to it. Let me show you this video. This is a space planning graph. It's more complicated, but I can tell you that this introduces some random seeds into the process, so that you'll see when we get up to that part of the video, as the slider moves around, you're actually going to get some non-deterministic results from here because of the random seed introduced. There's a bunch of fairly funky interactions going on in here between a bunch of prioritized spaces to place the perimeter, what the random seeds are doing,
Anthony, when was that you said that that'd be available?
End of October, we're, right now I'm actually doing a lot of stuff around writing documentation so somebody, every author can understand it. We're holding off for polish of that, and, I'm trying to make a splash at my RTC Europe class. So, that's happening like the third week of October, so I wanna give those folks the kind of first crack at getting into the source code, but when I say first crack, I mean by like a matter of a couple of days. So, probably the last week of October or so, we'll, publish the Git repository on this, and then, people can download the code and do whatever they want with it.
Cool. What else is it that the Generative Design Lab is working on? What is it else? What other things you guys working on?
Well, we're of course, maintaining the products we have. But a lot of what we're doing is, we're kind of looking at things like Insight, and which kind of, I don't know if you guys can maybe be provided a matter on to you about the Forge platform, but that boils down to essentially a business model and a technical infrastructure for taking a lot of cool stuff that our applications already do and turn them into services that people can combine and use. So, we're looking at Insight, daylighting, and energy analysis, and a crowd simulation thing we just acquired this year as possible future services. We're looking at obviously taking Fractal from alpha into something a little bit more robust. But the thing is, it's not super useful to show somebody 42 million possibilities. It's not a helpful tool. When that sort of production of options gets interesting is when we can start testing them against actual goals that people want to achieve, and then pulling out the simple bits, pulling out stuff that doesn't actually hit those goals and just never showing it to anybody. The more interesting stuff is to start a recursive loop where the graph starts to analyze stuff and try to converge toward a solution that satisfies as many of the goals as far as possible as they're set. So some of the things we're thinking about, for example, is they're not
is a loaded question I want to ask, but what do you see as the biggest influencer of the next 6 years of technology that you can perceive right now that will drive the way that we do design moving into the future?
Scalable cloud computing and machine learning.
Yeah. All right.
Like those computing technologies. I mean, the thing is, you know, as I had opportunity to learn at length to a colleague today, you know, we're not doing what you guys are seeing tonight, and you know, things you've seen around some machine learning stuff. I mean, none of this stuff is super radical. It's actually been kicking around in academia for like sometimes as much as like 40 years or more. So, but what seems to be a common characteristic of all this work is one, it always seems to like somehow arrive at a screen or, you know, some kind of display of a bunch of design options. And that the work never seems to go any farther than that. And the hypothesis we have is that that work never goes farther because it's so hard to build the computational infrastructure just to get to the point that you can try your idea, that alone is an accomplishment and enough to get you adopted. So we think that, you know, one of the things that Autodesk is good at is, you know, making, you know, robust, scalable applications that last for decades. Nobody is, you know, other than a commercial software company, nobody else is really good at that. But all those other people who use our stuff have really good ideas that they use on top of the stuff that we maintain for decades. We think we can do that with a scalable computational infrastructure. We think we can also hook machine learning into that as well. You guys may not be familiar because we haven't got a lot of play. We have something called the design graph, which is plugged into A360, which does, oh good, I see an arm over there. Well, that actually is using machine learning in the background to understand shape. So for example, if you do a search for a bolt, like just a text search, certainly we'll return stuff that's labeled bolt, but we'll also return everything that looks like a bolt geometrically. So, and that's all the machine learning algorithms. We point to thousands and thousands of samples to start figuring out what things were inside mechanical assemblies. There's no reason we can't do the same thing with AEC representation. So I think those trends of, you know, machine learning enabled by scalable computation are really going to change the way we approach design problems. All kind of evolving on to eventually, you know, human judgment, because the computer is not going to tell us what's important in context. It can only show us the implications of our decision.
Anybody else got any questions for Anthony before we call it? Well, Anthony, thank you so much. I know that you said you were up against the deadline. I appreciate it so much.
Guys, thanks so much. I appreciate your time.
Good night, Anthony. Thank you.
Bye.
Yeah. All right. So that is the main portion of what we had to go over tonight. So if you want to bail out, this would be your time. The other thing I want to give you a chance to do before we do that is we didn't have any time for questions really with Kenneth. So if you guys have any questions, please take this time to do that now. And then after that, we're going to grab some more pizza and we're going to get our laptops if you got some, or I brought a TV down with some dynamo, and we're going to build some stuff. And so if you want, hang out for that.
So Kenneth, I have a question. So you saw in the talk there, is how do we build in this kind of, so it's everything, you know, good is the enemy of great. So how do we build in this part of the equation that you're talking about into our normal processes so it doesn't have to become this discussion on ROI and this and that and the other? So how can we do kind of parallel worlds, for lack of a better term? How can we start to build those pieces in so we get that as a benefit without even asking for it. So, like, we try to leverage our models, our BIM models to do different things, and we build on that and kind of get stuff for free, so to speak. So how can we do that with your concept and bring that into our world? Because it's never going to get an audience because you have to prove it. And that's the whole point of you can't prove it, you know.
Yeah. So I think the right way to apply these ideas obviously depends a lot on what the domain is that we're talking about. But I think your world, which I don't necessarily know that well, but I have some idea about it. Obviously, I'm interested in what he was talking about. It seems like it's driven a lot by software and applications that facilitate what we're doing. So certainly the kind of treasure hunting process in the spirit of something like Pick Reader is very amenable to software. I mean, Pick Reader is software. So I think in this world, it's fairly straightforward to conceive that these tools, like the tool he was describing, would include the ability to go down serendipitous paths or even encourage it. And I don't see, I don't see any real prohibitive aspect of that. You don't want to make tools like this. In fact, I'm sure that maybe he not personally, but they're thinking about that. They're aware of these things. I've spoken to them. And I've spoken actually to, for example, an architecture firm that also wanted to create this kind of an application just for skyscraper design, but something that would be serendipitous. And so then you can imagine that you could leverage the engineers that you have as populations so that they could create those stepping stones. So basically, just one person is a lot less powerful, of course, since these systems are drawing off of the creative instincts of many people building up each other. So you have that aggregate of people, and you can potentially harness it pretty conveniently through software. So people have access to what their discoveries are almost immediately. And I mean, a big part of making these kind of systems work is access to the things that other people have discovered. Those are the stepping stones for you. So you need to be able to see those easily and get a quick sense of what's available. Well, this software is probably great for that. And internet, the cloud, things you were saying. So those are all great for that. So I just think it's a matter of, this particular domain is really implementing within software these kind of capacities. And they can be built on top of more objective capacities, which already exist, and are still, I'm not trying to say those shouldn't be used. Those are still used for especially when you're getting close to where you want to go.
Right.
But they can be, integrated together, so they dovetail well.
One of the things I've seen on a lot of the neural network stuff is that, they'll train a neural network with images, and then it'll recognize things. But then they can also, in reverse, feed it, or tell it, this is what I want to see, and then it goes in reverse, and then it can output something. With something like the Pick Reader, obviously it's working in the one direction. What happens when you go back the other way?
Yeah. So you're talking about, so one kind of neural network, you can show it a picture and it'll tell you what it is. That's one kind of neural network. So it's like, is this a dog or a cat? And they'll say dog, and hopefully it's correct. But then you're saying the other way might be, I tell it dog and then it outputs a picture of a dog. Is that kind of like what you're saying?
Yeah.
Yeah, so actually, so those kinds of systems do exist. They're much more exotic than the first type. I mean, the type that just does recognition is pretty well established at this point. And there are versions of that have world-class results. And some of you may have heard of these things, but like deep networks are getting better than human performance on certain types of image recognition tasks. But the other way around is like generating images. That is like a much more open topic right now. And there's now the Pick Reader is generating images. I mean, in fact, it's an example of that. Because Pick Reader is not classifying anything. It's not like they're showing you pictures and then it's like I showed it a car and now I drew a car. That didn't happen. But in fact, but the Pick Reader version of image generation is very human driven. Obviously, there's a human in the loop. So there's actually a lot of different ways that image generation is being explored with neural networks. And Pick Reader would count as one, because really inside is a kind of neural network. but some of them are human not in the loop versions of this. And those will be trained, so it's different than pick reader, trained in the sense that they'll be presented with thousands or millions of images, and then their job is to understand what that class is like. So if you showed it like thousands of dogs, then presumably it could generate a new dog for you that you've never seen before, or faces or whatever. So if it sees enough data, then it can create a model of that particular space of faces and space of dogs, and then it can just generate arbitrary exemplars of that particular class. And these kinds of models are rapidly improving. I mean, they exist, and every week you hear something new. But they're still they're not quite at the level of I think they're not quite at the level where it's commercially viable yet. Like if you really look at these things, like a lot of times you look at a paper on something like this, quite impressive at first. Whoa, it just invented all these things. If you look really closely, you'll see flaws. Like, oops, actually that dog had 3 eyes, or actually it's extremely low resolution. It looks pretty good, but it's like like a 20 by 20 pixel grid, so you couldn't really use this in anything. These are often the caveats that come with these systems right now. So people are trying to increase the realism and the consistency of the imagery, and guarantee better, not guarantee, but make it more likely that this actually doesn't have a flaw like having 3 eyes. And also increase the resolution dramatically, so that it's like real photographic quality, which obviously it isn't at the moment. So this is like a technology that's right in the middle of progress, I think, right now. We'll see rapid advances in the next few years.
And just my question, showed my ignorance that, I'm trying to wrap my head around still, what is a neural network? AI is AI a neural network? Is deep learning a neural network? Is that AI? All these different facets, and then still just trying to wrap my head around what types of AI are there? AI isn't a singular thing, kind of like what you're going, my mind wasn't even there when I asked the question, and you're going, well, that's one type, and there's another type.
Yeah, that's a good point. There's a huge diversity of things that we would call AI. And the field's been around for more than 50 years, so over that time, there's been thousands of different sub-areas and fields and so forth. Some of them have died out and didn't work out well, and then other ones are still going. And it just so happens that today, this thing called deep learning has been winning out. Has anyone not heard of deep learning? So that's a great example of just how amazingly dominant that is. I mean, you couldn't have said that 10 years ago. But suddenly deep learning is like now a household word or something, which is quite amazing to people like me. But deep learning does refer to neural networks, basically. So they used to be called neural networks. About 10 years ago, they started being called deep learning, which was a really good marketing idea, apparently. So now it's called deep learning. I mean, it refers to a certain type of neural network. It's true, it's not like there used to be shallow neural networks, now they're deeper, so that's why it's called deep learning. They have more layers of neurons. But it really isn't like a concrete difference between today's deep networks and the old school thing we used to call a neural network, which is a deep neural network. So neural networks have suddenly become dominant in AI. So a lot of people today actually think that neural networks are AI. Say AI, we're talking about deep learning, but there's so many other things. So a lot of people would be offended, in the field, to hear that, but that's just what's happened. So excuse me. That sub-area has come to dominate now. And it's partly because it's been successful.
Yeah.
So it's done a lot of human-level stuff. That's gotten in the news, gotten in the New York Times. People have seen it now, and so sort of it's winning out. But that's not necessarily going to be the future. That could change.
Yeah.
So that's the kind of trend of AI, is that there's constant waxing and waning of areas. It's not very common for something to remain dominant for long. But at the moment, it looks, like deep learning is just killing everything. So today we can say that, but things could change. So from the perspective of if you're outside of AI, it's like you're trying to get a grip on what are all these things. The answer is very difficult, of course. I mean, there's nowhere you can just go and just get a list of, okay, here's all the ideas in AI. Of course, you can buy a textbook, might be a bit out of date, since things change so rapidly. But that is like probably the best option if you really, if you really want to say, well, what are all the different AI techniques? By an introductory textbook on AI. Neural networks will be in there, but so will many other things. And each one of these things is good for different types of problems. Like the neural networks are not good for everything, but they just happen to be good for things that are more sensational today. Whereas other things might be good for stuff that has been, it's harder to get in the news, but it still might be useful for certain types of things. So yeah, there's a huge diversity, but it's really hard to just say, okay, well, here's what AI is. It's just these things. And in fact, within AI, there's a lot of controversy, of course. So you won't get any consensus on this. Or like, what's the most important thing in AI? People will just say whatever they're doing is the most important thing in AI. So it's very hard to get like a definitive answer to what should I be looking at if I want to look into AI. Probably the best answer today is deep learning. It's just that's the hot thing. I mean, if you're coming from outside, although there's many other things that might be of interest, that is at least proven itself to be cutting edge in certain ways today, and would allow you to be conversant with a lot of people who are now jumping into that bandwagon.
So Elon Musk
Yes, sir.
open source AI.
Yeah,
And-
right. OpenAI.
Yeah, so he and Steve Hauck and another also asked the question. They had some apprehension about AI and that StarNet or Skynet, whatever it is.
Right.
What should everybody be thinking about in terms of AI? Should they be educating themselves, or should it be how should we be thinking about AI in a bigger picture?
Yeah. So what you're referring to is that these people have been, many other people have been warning us that we could be facing like the end of the world or something terrible because AI could be about to take over, or maybe not about to, but maybe in our lifetime or something like that. I think it's a complicated issue because on the one hand, it's probably that they probably are not sufficiently informed to really be giving us a realistic picture about how bad the situation is. But on the other hand, you wouldn't want to just dismiss this issue and say, well, we don't have to worry about it. I think we are not on the cusp of computers taking over. That is just not about to happen. That's my opinion. There's no Skynet about to happen. Just because a deep network is good at classifying 1,000 different classes of images does not mean that like there's going to be a deep network running for president next year. So really, there's a huge gap between the state of the art and human level currently, and no one has a clue how to bridge that gap. So it's true that the progress is happening, and so it could happen. If we bridge the gap, I think at the current rate, it'll take a long time. But then we have to admit that it may not be never. I mean, it could happen, I guess. And so we shouldn't be panicking, but we should be, I think, aware of like the potential ethical issues that come with that. But in a kind of sober way. We're not like warning the end of the world is about to approach. And probably like really the issues that matter are more mundane, but the problem with those kind of warnings is they actually distract us from the actual problems that we might actually like really face, like things like computers taking over too many jobs and causing like a surge in unemployment in the short term. And these kinds of things are probably more dangerous just in the short term than like these killer computers taking over. And they're like real and present dangers. They're more complicated and also less sensational because I mean, it's not clear that maybe new jobs will be created, and then economists debate about this, and maybe it'll all be okay. But so we're not totally sure this is a disaster or not. But it does look kind of weird, like what's going on. That who will replace? What will happen to all the maids when robots start doing the rooms in the hotels? I mean, it's not completely clear what happens with all this in the end. So I think that's more immediate. Those kinds of things. And the Skynet is way off there, but still can't be entirely ignored. So it's like the kind of somebody should be thinking about it. And like there should be some degree of ethics instilled in the field, like that people working in it should be responsible for the consequences of what they're creating if it could have been prevented. I mean, we should be aware of this, I think. And so it's worth at least raising the issue and talking about it. But it would be just panicking and premature to say this is like an immediate danger that we should all be scared of. So that's my take on it.
If nobody else has any other questions for him, let's call it a night, and then those that want to do some dynamo after a couple minutes here, grab some drinks, and we'll come back to it.